Electrical substations are critical components of our power infrastructure. They also contain high-voltage equipment that presents serious and potentially fatal hazards. This video provides a general overview of electrical substation safety and outlines minimum expectations for anyone entering or working in these environments, consistent with OSHA regulations and NFPA 70E standards for electrical safety in the workplace. Before entering a substation, it's important to understand one core principle. Always assume all conductors and equipment are energized unless formally proven otherwise. Both OSHA and NFPA 70E require equipment to be treated as energized until it has been properly de-energized, locked out, tested, and grounded. High voltage does not require direct contact to cause injury or death. Electrical energy can arc across air gaps, travel through tools, and transfer through the ground. Electricity is silent, invisible, fast, and complacency is one of the greatest risks. Access to substations is strictly controlled. Under OSHA 29, CFR 1910.269, only authorized and qualified personnel may perform work on or near exposed energized parts. All access must follow approved procedures, permits, and switching orders. Visitors and unqualified personnel must remain under escort at all times. Never bypass gates, locks, barricades, or security systems, and always follow posted warning signs and site instructions. Personal protective equipment, or PPE, is a critical layer of defense. NFPA 70E requires PPE to be selected based on the task, the equipment condition, and the level of electrical hazard present, including arc flash and shock risk. Required PPE may include flame-resistant clothing, hard hats with appropriate electrical ratings, eye and face protection, voltage-rated gloves with leather protectors, and electrical hazard-rated footwear. PPE must be inspected before use. Damaged or compromised equipment must never be worn. Maintaining safe approach distances is essential when working around energized equipment. Both OSHA and NFPA 70E establish minimum approach distances, or MAD, to reduce the risk of electrical contact and arc flash exposure. These distances apply not only to workers, but also to tools, materials, and equipment. Long or conductive objects can unintentionally breach safe clearances if not properly controlled. Take the time to read and understand the minimum approach distances that are listed at each station. Though it is not required, some substations will post MAD requirements on the gate. The information could be posted in multiple locations around the sub, such as the control room door or the side of the switchgear itself. All personnel entering the substation must be qualified. Follow entry procedures, which may include notifying control centers or creating an entry in a logbook. Grounding is another critical safety consideration. OSHA 1910.269 requires proper grounding of de-energized equipment to protect workers from induced voltage and accidental re-energization. Even equipment that appears de-energized may carry induced or stored energy. Step and touch potential may exist, particularly during fault conditions. Only approved and properly rated tools and test equipment may be used inside a substation. NFPA 70E requires tools and test instruments to be rated for the voltage and environment in which they are used. Inspect all tools before use. Keep work areas organized and ensure tools are positioned safely away from energized components. Conductive tools should never be used unless specifically designed and approved for the task. All work must follow approved job plans, job hazard analyses, and switching orders. NFPA 70E requires a documented risk assessment before work begins, including identification of shock and arc flash hazards. No task is so urgent that it justifies unsafe behavior. In general, we do not work in substations that are undergoing construction. The number of hazards present during construction activity is significantly higher. Take care to stay physically clear of operating switches and buttons on panels. Ensure you and any equipment will not inadvertently operate a control. Good housekeeping supports safety. OSHA standards require work areas to be maintained in a condition that minimizes trip hazards and unsafe footing. Keep work areas clear, secure loose materials, and be aware of uneven gravel, cable trenches, and grounding grids. Environmental conditions such as rain, fog, or lightning can significantly increase electrical risk and must be factored into work decisions. In an emergency, knowing what to do can save lives. Workers must be familiar with emergency exits, first aid kits, fire extinguishers, and site-specific emergency contact information, as required by OSHA emergency response standards. If an electrical incident occurs, do not touch an injured person until the source is confirmed de-energized. Call for emergency assistance immediately and follow established emergency procedures. All incidents, near misses, and unsafe conditions must be reported in accordance with company policy and regulatory requirements. Electrical substations are unforgiving environments. Safety depends on preparation, awareness, and strict adherence to OSHA regulations and NFPA 70E safe work practices. If you are ever unsure, stop and ask. Your safety and the safety of everyone on site depends on it. Whether it's a falling object, a moving vehicle, electrical current, or even noise, injuries happen when energy is released in an uncontrolled way. The challenge isn't that we don't care about safety, it's that our brains naturally miss certain types of hazards. That's where the energy wheel comes in. Let's break down the energy types represented on the wheel and how they appear in real work environments. Gravity hazards involve falling, dropping objects, or loss of balance. Examples include working at heights, uneven surfaces, or unsecured materials. Motion energy comes from anything that moves, vehicles, equipment, or flying objects. Traffic, swinging loads, and rotating machinery all fall into this category. Mechanical energy is stored or transferred through machine parts. Think of gears, belts, springs, vibration, and pinch points. Electrical energy includes live wiring, power tools, extension cords, and energized equipment, even when it's not obvious or visible. Sound energy comes from loud equipment and tools. Prolonged exposure can cause hearing damage, even when no immediate injury occurs. Pressure hazards involve compressed gases or liquids. Pneumatic tools, hydraulic systems, pressurized tanks, and tires are common examples. Temperature energy includes both heat and cold. Hot surfaces, friction, steam, extreme weather, and cryogenic materials all present risks. Chemical energy refers to substances that can harm the body. This includes solvents, fuels, exhaust fumes, dusts like silica, and corrosive materials. Radiation hazards include ultraviolet light, welding arcs, sunlight, lasers, and certain industrial processes. Biological energy involves living organisms or pathogens, such as bacteria, viruses, insects, animals, or contaminated materials. The energy wheel is a simple, evidence-based tool that helps workers identify all types of hazards. It prompts teams to think beyond instinct, improving awareness and safety discussions on the job. Using the energy wheel can improve hazard recognition by up to 30%, making workplaces safer and protecting lives.